Hey Math 6, happy Wednesday. Hope everyone's doing well and that you've enjoyed the start to our unit on geometry. We're going to continue on with geometry for the rest of this week, next week, and probably even a little past that. So settle in and enjoy learning about something new. We are focusing on 2D figures, and today we're going to transition into a little review slash study of angles for the remainder of the week. So as always, make sure you have that charged Chromebook. Some of these terms might be new to you, so you might want your math binder or paper nearby so you can jot down some examples and some definitions, and then we'll get started. So our goal today is to be able to identify and describe different types of angles. All right, so when we think of angles, we know that they're measured by degrees, but you might be wondering, as students often do, like, how do we get those degrees? Where do they come from? We're going to talk about precise measurements and measuring with a protractor later on this week, but I want to do a quick little introduction to why we have angles that are measured the way that we do. So if you guys have ever heard the term like, oh, they've done a complete 180, or if you do a 360, it's a complete circle. So you might have heard people say 180 or 360 before. Even if you're turning, like turn around 360 degrees, that would mean you're turning around and you're facing the same way. So a circle is measured with exactly 360 degrees, which is pretty cool because when we think about sunlight and a year and our rotation as a planet, we can think that the year has 365 days. So that's a cool connection right there. So if a circle has 360 degrees, if we split it in half, each half would have 180 degrees. So that straight line, the whole circle measures 360 degrees. That straight line would measure 180 degrees. So that is a straight angle. Straight angles measure 180 degrees. If we cut that in half, so if we cut the 180 in half, now I'm going to cut vertically. How much would one section be? So it's 360 cut in half to 180, and then 180 cut in half would leave me with 90. So here we have what you probably know as a right angle measuring at 90 degrees. And 90 times 4 is going to give you 360. So we know that there are 4 right angles, 1, 2, 3, and 4, that make up an entire circle. So 4 90-degree angles come together can make a full circle of 360 degrees. So when we're talking about angles today, and we're talking about right angles or straight angles or acute angles or obtuse angles, and you're like, what in the world is she talking about when she says 90 degrees? You can use this to help you remember. So a full circle is 360. The straight line is half this, cutting the circle in half is 180. And then splitting that in half is 90 degrees. Okay, all right, let's take a little closer look at some specific types of angles. Oh, but before we do that, I want to show you quickly how angles are named and how they're written when we're describing them. So here we have an angle, and what an angle really is it's a formation that's created when 2 different rays have the same endpoint. So earlier this week you learned about a ray. A ray has an endpoint and then extends forever and ever and ever in two directions. So this happens when we have two rays. We have ray GF and we have ray GH, and they share the endpoint or the vertex G. So an angle is created when two rays share the same endpoint. Again, that endpoint, as we now know, is called the vertex. So the two rays from the side form the angle. And we write angles, you can see up here, we name angles by their vertex and the other points. Okay, so this angle you'll see is called angle FGH. It could also be named angle HGF. And we name an angle just by drawing a little picture of an angle in front, and then we say a point, the vertex, and another point. So notice that no matter what, the vertex or the end point is always in the middle. And don't worry, we're going to practice writing some of these today. All right, let's do a quick review of types of angles. You have probably heard of these and seen these before. So a right angle is an angle that measures exactly 90 degrees. No more, no less. If it's 90.2, it's not a right angle. If it's 89.9, not a right angle. It's exactly 90 degrees. I think of this as a perfect L. Often, not always, but often, you can know that something's a right angle if it has the little box in the corner. But again, not always. All right, when we move less than 90 degrees, we're forming an acute angle. An acute angle is anywhere between 0 and 90. So it could be 0, very, very small. It could be 45, it could be 60, it could be 70, 80, 90. Once we hit exactly 90, it's a right angle. So actually that should say like 89.9. So an acute angle is less than a right angle. If we have an angle that's larger than a right angle, here's our right angle. If it's larger than a right angle, it's called an obtuse angle. So an obtuse angle is anything from 90.1, for an example, to 179.9. So obtuse angles can be just a little more than a right angle, or they could stretch almost to 180. When we reach exactly 180, that's what we call a straight angle. Remember back from our circle, it's a straight line. So right angles and straight angles have only exact measurements. Right angles are exactly 90, straight angles are exactly 180. Acute is less than 90, and obtuse is greater than 90. So we're going to take a look at some different examples of angles. We're going to identify them, we're going to name them, and we're going to practice writing them. Remember, when you're writing an angle that you are using 3 points, and the middle point has to be the vertex. That's the end point that the two rays share. All right, here we go. Feel free, if you jotted down any of the examples or definitions of angles, feel free to use that as we do a little practice. If you want to pause the video now and rewind and jot down some notes for yourself, please do. That's a great strategy, and it will be good to have almost like a little reference guide. And I'll look for one online to post on our Google Classroom as well. So what I do when I look at an angle, right away I ask myself, okay, is it 90 degrees? Is it more or is it less? So here on the screen, if it was 90 degrees, guys, it would make a perfect L right here. Or it would make a perfect L right here. But either way, we can see that it's more than 90 degrees. All right, and then I ask myself, is it a straight angle? Nope, it's not straight. So if it's greater than a right angle but less than a straight angle, we know that it has to be obtuse. Yes, it is an obtuse angle because it's more than 90 but less than 180 degrees. Now I want you to think of how you would name this angle. So if you had to write it down, what would you name it as? You try it and I'll try it and then we'll compare. All right, here are my names for my obtuse angle. As you can see, either of these would be correct, and they have a commonality. Both of their middle letters are W because that's the shared endpoint, what we call the vertex. All right, let's try another one. Okay, give it a shot. Tell me what you think. This is an acute angle because it's less than 90. Here would be 90 degrees. This is less than 90. And I would name this angle STU or angle UTS. All right, give this one a shot. You can just be thinking about it or you could jot it down. Angle ACW or angle WCA is just barely an obtuse angle. Because again, if it was a right angle, it would be a straight line up. Also, if you're not sure, you can always take a piece of paper and hold it up to the angle and see if it makes in the corner a perfect L. Okay, here we have angle GHI, or you could name it angle IHG, and this is a right angle. It is exactly 90 degrees. It makes that perfect L. Angle DEF or angle FED, and this angle is an acute angle. It looks to me like it would probably be about 35 degrees, because straight up and down would be 90. Half of that would be about 45. So I just kind of like to estimate what the angle is too. But it's obviously less than 90, so it's going to be an acute angle. And here we have angle PQR or angle RQP, and this forms a straight line, and we know that straight angles are exactly 180 degrees. What happens if we see something like this? Whoa, I see a pentagon with a star in the middle. Miles and Tyler, my challenge for you is to try to draw Try to draw a star like that today. I miss seeing your star drawings. And then send it to me so I can see how you're doing. So if you are seeing a picture like this, I could ask you, what type of angle is angle DEA? So you would have to look for angle DEA, knowing that E would need to be my vertex. So here we go, angle DEA. So that's the angle formed right here where my mouse is going over. And that angle would be what? What type of angle do you think that would be? Obtuse, yes, because it's greater than 90 degrees. It's greater than that perfect L. What about angle BCE? Find angle BCE. All right, here we go. Angle BCE. That would be an acute angle because it's less than 90 degrees. It's less than that perfect L. And let's do one more. How about angle DBA? We have DBA. Well, that makes a straight line, so that would be 180 degrees. It's a straight angle. All right, guys, that's it for our little overview on angles. Like I said, we're going to be talking about it for the rest of the week. Please head over to Google Classroom for today's assignment. Have fun with it. It involves a little color and a little observation around your room or your house. As always, email me if you have any questions. I miss you guys, and I'll see you tomorrow at our Google Meet. Bye.